Welcome, I'm Bill Wake. We're here working on a programming language interpreter using a technique called threaded code, and we're working on the read part of the read eval print. So we've got the eval working for primitives, and we're working on reading multiple lines today. So I think I can remind ourselves what we were seeing. So the problem is if I just hit return, okay, I get word not found, and if I try and select to see what that word is, I think there's just one space that's the normal space after the colon, and it's an empty word, and top of stack is still 0. That's unchanged. So if we do 3 words, well, multiple words, our traditional one dupe add, well, yeah. Okay. We get them, each word is processed. So 1 is still 1, duplicate is 1, 1, and add is 1 plus 1 equals 2. Now this little prompt in the way, this is all kind of an artifact of the fact that we print after every word executes. And I don't want to do that in the long run, but it's kind of just acceptable for now. Okay, let's see, one thing before we get going. Offline yesterday, we created an assert string equals, and I had it in one of I think it was an input tests. I moved it over to AS unit. I figured that wasn't too exciting. So, okay, so repeat readLine if no words in a line. I think that's where we're going to work today. Okay, so, yeah, we left off the difficulty of testing that with what we have. All right. We have a little stub now. And the stub just, it really only handles one string. So we have, the setup is there's a pointer, that's read source up at the top. Okay. It starts out, it's just a quad, so it holds 64 bits for a pointer. And the setup is you'll put the pointer to whatever you want to test on, like read source 1. You would put that into read source, and then the test could run. We really need to make that more of an array of things. Okay, we haven't done arrays at all, I don't think. It's not, I don't think it's going to be terribly difficult. Okay. Yeah, we started writing the test and said, oh, we can't do it. Okay. Because what we need in our test is we want to see a new line, empty string, and when it sees that, we want it to go, oh, there's nothing on this line. I should go get a new line. So we want to give it an empty string and then give it a useful string and make sure it parses the useful string. All right. Let's see. So I don't know if quad. There's really fill is the one that does the job, I think. And unfortunately, Apple doesn't document their assembler really. So new assembler quad. I don't think there's parameters on that. Well, that's interesting. Let's see, quad. No, that's something different. Okay, maybe this is probably it. Yeah, at least this is the page we usually go to. Quad big nums. Okay, 0 or more numbers. So it doesn't really give us any repeating unless we just put them in there. I don't know, maybe we could do that. I don't need a lot, right? I mean, like 5 or 10 is probably enough. Okay, so let's find that routine. Okay, so I'm going to make this an array. I'm just going to make 3, 4, 5. I don't think we have situations where 5 is too many. But I think we can, Well, it's like, do I want to make a whole facility out of this? Ugh. I guess I do. Okay, so I'm going to make L read index, make that a quad as well. Okay. And I don't know, this is all towards a test. I think we'll code it up ourselves and then use it in the test and let the test that as well. I don't know. I don't want to get too elaborate, although I seem to be heading that way. Okay, so let's make an L stub init. Okay, and I guess it's going to be a return. Okay, so what it's going to do, well, is that helpful or is a macro better? Let's make it a macro. Macro L stub init. Okay, and the macro is just for this test, at least for now. Check out these. So macro name and then parameters. Okay, we don't need any parameters. L stub init and macro. Okay, and all I'm going to do is load address x0 with L read index. Yes. I'm going to store 0 at where x 0 points. Okay. And I guess to keep with how I do macros, it's really this. I don't think it's going to harm anything because it's local. Nobody else will see the macro, so I don't need to restrict it like that. Okay, so stub init uses x0. And what it does is it resets stub array index. Okay, so I think I will say the thing to do, and we are not changing x0. Maybe we should. Store x0 plus 8, post increment 8. Okay, so we're storing it in here, and then next thing we're going to point to the array. Let's call it lread read source. Read source. Read source. Okay. Okay. I guess the output is x0 points to array. And I'm imagining our test will use this. So stub init. And then we're going to put data in. Okay, so let's call it lread source multi-line. Multi-line empty. ASCII Z new line. Then we'll have L read source multi-line non-empty ASCII Z 1. Okay. New line. Okay, and our setup is going to be, we're going to have to put this address and then the next address. Okay, so x0 is the next address, so we're going to be load address x1 gets this, and then same thing, non-empty. And then we're going to store x1 into x0 plus 8. Now that's prime macro area then. Okay. Let's stub add. Okay, this goes to slash label. That's like it is. Okay. And I keep bumping that build. Okay, well this part seems good. So we just say initialize the stub, add in a couple of lines, and then I don't know, the name is not as good as it could be because stub. Yeah, I'll make the new test work, and then we can fix those others. And then I want one more thing: is stub ready? Okay, and I'm going to put a 0 in where x0 is. Okay, x0 is not interesting to us at this point. Okay, so that to me, that sets up a series of pointers to the data we want. Now we got to make our stub use them, and I really only care about this test for now. The others, because of the way they work, they probably are okay because they're only going to use one, and then well, before we do any changes, okay, let's do this. Let's do a make. Okay, everything's looking good so far. I don't see any funniness. Okay, so that's good. Now I'm going to flip it. Well, I'm going to comment these guys out because we pretty much have gotten rid of tokenize. So that'll be fine. These three, though, I don't want to get I want to get the stubs and the read line thing working before I go back to them. Maybe we'll get this one working and then add one or something. Okay, yeah, that probably can be done the same way. Okay, so read word. All right. So what we're going to do is we're going to load. Well, do we need any? You know what? I'm gonna duplicate that function instead. Let's keep these working. Okay, so I'm gonna take this stub, the read line, and work with that. Is that gonna check things? Yeah, I think that'll be okay. I'll call it readLine 2. It will consolidate them at some point, but just so we can keep everything working and independent at the same time, I think that will do it. Okay, so we still have to do this. We load the address of our stub, readLine 2, and then we call readWord, and then our expected is load address x1l expect I'm going to change these names. Read l expect multi-line 1. Okay, so this I haven't defined yet. Okay, I think that makes it. This works as long as you have stub in it to them, but they might be cleaner. Yeah, I think we probably would be okay, but I'm gonna take it smaller bites. Because what we're doing on the production side shouldn't care about the stub, because mostly it's going to call it once, except for this last test. So I think we're okay. Line 186. Ooh, thank you. Did I call it something like that? Expect read multi-line 1. Okay, so this should, I think this will run and give us an empty string. Okay. Okay, x0 goes to empty string, x1 is 1. Okay. That doesn't feel so bad. All right, now this thing does not do anything yet, so we'll need to work on that. Okay. x0, x1, x2. Well, x0 is read source. Yeah, we're going to have to muck with things a little. I want to read line 2. Okay. We're going to load index first. So wherever that got off to, L read index. Well, maybe X. So right now we ignore everything. Well, this is all right, we need the address. Let's call it X. 9. Index. Okay. And then read source. There's a mode. All right. So let's go down to our modes. There's a logical shift left mode that's sort of designed for this. Let's see. Immediate offset. Yeah, it's this last one. Register offset with shift. So we want to take this times 2 to the nth and add it to that. Okay, so RA, RB, LSL pound something. Okay, now these are 8 bytes. Okay, so if we have x0 plus x9 times 8, right? So because it's 8 bytes per entry, and x9 is telling us how many bytes. So if it's 0, it's 0. Next is 8, 16, and so on. That should get us accessed off x0 to that phrase. Okay, so this should behave the same way because we haven't done quite enough yet. I'm just making sure I don't break anything. Yeah, okay, well is that a problem? Should that have broken anything? Okay, let's stop in here. Okay. LDB input tests. Break set minus B. Stub read line 2. Okay, we'll run. Reg read x0, reg read x9. Okay. It points to data holding the index. Oh, we gotta load it. Right. Okay, back where we were. Thank you. All right. So at least if we don't update the index, that's what we get. Let's update the index. Now this, in a perfect world, this is a little slow, but it's simulating I/O for a test, so I'm not going to sweat an extra memory access. Okay, we don't want to screw with x0 though, because, well, nobody looks at that. Okay, never mind. I'll read index. Let's do load x10 with contents of x9. Actually, we can do add. Ooh, I don't know if we can or not. X10 with the contents of x9 as well as 1. And then we want to do a store x10 to the contents of x9. And this should be 8. Okay, so I'm trying to move that index 8 forward. Okay. I guess when we get to the end of this routine, we can look at memory and see. Okay. So make. Yeah, it doesn't like that. Okay. Let's load address x9. X10. Let's load X10 with the contents of X9. X10 gets X10 plus 1. And then store X10 at the contents of X9. Okay, a little clunky, but livable. Okay, and now let's see what's going on. Nope, it's like stub readLine new. Okay, so there's our store X30. Let's make sure. Okay, load address. Step, 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 step. Another address, another address. Load that. Okay, let's see. X0. X9. Okay. X9 is our index. Okay. Now I'm gonna step X0 should be the same. Oh no, is it bigger? He's oddly bigger. 61 bigger? All right, let's mem read minus C 200 here. No. Here. X0 is supposed to be... Oh, we've already loaded. Reg read X9 is still 0. Okay, I'm gonna do a next over it. And step reg read X9 mem read minus C 200. X9 is supposed to be our index address, so that should be the beginning of a block of stuff. There's 8 bytes there. For a little grouping would help visually. All right, and then 014097 0 1 2 3 4 5 6 7. That's our 0A. Okay, that's a good sign. Yeah, points to new line. Okay. And then we're ready to increment X9. Okay, so step, 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 step. And I'm going to continue because we're going to get that same error we've been getting. Because our code doesn't do anything different. But I think, let's see, can we do a mem read still? $4030 is not a S1. Okay, I don't know if it updated that index correctly. So, I mean, we're hoping that read index comes in. Notice we did not break on stub readLine 2 again. So that tells us our input code, or, well, at least it's because our input code only reads an address once. There's no loop across the whole thing. All right, now, so I think well, the question is, when am I well, the problem is if we come in for read word, and there's no word. Okay, if there's no word at all, we come into an empty pointer to an empty byte, or rather, we're going to reload. But if we come in and it's not an empty byte, like if it's a new line, we're going to go to word start, and we're going to skip over spaces and new lines. Is that right? No, we're skipping over spaces, of which there are none. And then we move forward until we hit a new line. And we hit it, and when all is said and done, we're down there at the store byte in 97. Well, no, what I'd like it to be is I want it to go out and get another line. At least that's been my assumption. When read asks for something, it should get something. And if it has to do another line or two or however many blank lines, it should keep going until it gets that. So I'm treating this input side as a little subsystem whose job is get me the next word. And if he's how do I say that? Yeah, so I just want him to keep going until he gets a word, because that's his job. Once he does that, then I don't need to print after every word. I'll switch to a print only after. Well, if we print only after the words are actually executed, not any empty words. Okay, but so the problem is here. Let's see where we find the word. Right somewhere. What do we do in the end? We point to the word with x0. So we're expecting x0 to point to the word, and that's being set here, which is probably worth at least a little comment. Set the return to point to this word. Okay. But I think he's got in 89 he's finding the trailing space, so he's walking over all the letters in the word. The problem is we've left him with nothing, so there's no space. All we have is a new line. So when he comes looking for a word start, he doesn't find anything, but we've assumed you'll always find something, because we skip any spaces, and then you're supposed to find something, and he doesn't. He just finds that new line. And so he points to it, but then he's going to look for find trailing space or new line. He's going to point to that new line with x22, and then go back in 97 and zap the new line with a 0 byte. So let's see. So I'm not sure the point where we have to do this, but I guess like here, if this word is empty, well, we don't even know that there, do we? We've set the return value to the pointer to the return, the return or the new line. Yeah, if x22 points to a new line, we should read. If it doesn't, well, no, it's really more complicated than that. We have to, I guess, if it points to a new line when we start, yeah. So if we're here and we're pointing at a new line, we need to go back. If we succeed with that, this test will fail. Sorry, yeah. If we go back, we keep going back until we get here with no new line, but he still might have to look for a new line. So I think that's what it is. So let's compare. Let's peek LDRB W1, and I don't think we're using W1 up there. No. Okay, so W1 to contents of X22. I gotta learn to write that. Yeah, like that. Okay. Now, W1 to OXOA. And if it's equal, then we hit the end of a line. At end of line, go back and read more. All right, and where do we go? Well, if it's a new line, well, maybe I want to do this. Well, if it's a new line, right, I should move the pointer one and expect this to trigger. Okay, so let me do it this way. If it's not a new line, then we're going to go to find trailing space or NL. Okay, if it is a new line, then I'm going to add 1 to X22 and branch back to I'll check if at end. Okay, does that seem right? Okay, so we've skipped any spaces. If we're at a new line, we're going to load that byte. If it's a new line, we'll compare it. If it's not a new line, we'll go try and find, the rest of the word. If it is a new line, we increment, so we skip past the 0A and to what is presumably an end byte, and then branch back to the top. Yeah, I guess to be a little structured. Yeah, I guess this is okay. If it's a 0 byte, it should be, then it does this stuff. The case I'm in my head is like, what if it's ABC, new line, DEF? Well, that really doesn't happen the way we're working, but I don't see a problem with it. If it doesn't find the 0, it's going to look for spaces. It doesn't find spaces, it's going to look for a new line. Well, it's on the DEF, Yeah, so it would work with multi-line strings, I think. But that's not our problem here. I just want it to work for what we have. We know the way we're setting up our IO and stuff. We're going to have a new line followed by an end of line. So, all right. So the theory is this should just make and work. Okay. I always feel a little like I've jumped over the line a little too hard or something. That hill you weren't expecting, read from new line, only line. Oh, did I not run the test? No, I must have. Must have is strong. Read from new line, only line causes read line. Okay. Well, I think that works. So let's run our REPL. And so if I do nothing, it's really asking me for more input. Is that reasonable? I don't want the input prompting per se. Or if I do, Okay, I think that's sort of barely acceptable for now. I think what we probably will want to do is move the prompt into the read, but I don't know, that sounds a little bit odd. But it is kind of what we want. At least for a read from the terminal. From a file, we don't want to see boom, 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 10, 10, 10, 10, 10, 10. All those printed out just because we read 50 lines. But I think this is okay-ish. It's always these trade-offs, like, trying to move forward on things. And this is sort of a UI defect. Well, it is a UI defect, but when we're at a language where you can add, subtract, multiply, but not divide, and you can't do an if yet, and you can't do this, and you can't build your own methods, those all feel more important to me, so that's where I'm holding off. But anyway, what we did was we make read word, grab another line if at end of line. Okay. So this twists the responsibility for getting new lines into the read word out of any REPL stuff. Okay. So I think that's good. 240. Okay. Yeah, I was kind of afraid that would take an hour or an hour and a half to get right, but I think we've gotten it. All right, now I want to do some cleanup. Well, let's keep track of things first. Repeat read line. Okay, so this is 22. I don't remember what I called it. Read multiple lines. Okay. Clean out, tokenize, and eval. All right. So as we are now, tokenize is dead code, but it was tested, and we want to make sure that there's no tests in there that that we don't cover. Okay. Does nothing with an empty string. Move x1, 0. Assert equal. Okay, this has actually been made obsolete because the test we just did is really the test of empty lines. Okay. All right, so that was this one. Now replace new line with 0. Well, I think we've established that one. And what about this one? Replaces spaces. Okay, yeah. So before we had a very primitive, it would only deal with one space at a time and not handle multiple spaces. I mean, we knew we had to eventually, but I think we've adequately tested all those. Okay. Let's make. All right, and then, okay, let's look for tokenize. Oh, there's still, oh yeah, we don't need the global, don't need the method. Input init, that's still important. Okay. Input buffer. All right. Okay, so I think we've got it. Read word. Get next word, reading new lines if necessary. Okay, so we'll save that. All right. We're getting quite a pile of tests there. I don't know what to do. Each one's independent, so... All right. Then we've removed tokenized. Okay. Now, let's find interpreter. Well, let's just say eval. Here's REPL.s. Okay, so I want to find anybody who's using eval. We got tests, and that's it. Okay, so let's focus on the test first. But is anybody else calling it? Who's this? No, that's eval. Okay, so let's see how we feel about these tests, I guess. Ooh, that's a good one. Eval of empty string stops. Well, we've just made it so that can't happen. Okay, he's using L empty string. Oh, excuse me. Eval of just 42, push 42 leaves 42 on the stack. Well, let's see. Does our eval tests... We don't have an eval 1 test, do we? Oh, okay. I think this is a legitimate concern. This probably needs a new line to match our input buffer. Dictionary and NID. Oh, no. This is almost like... Well, okay. This is eval. So eval is really looking up this word directly. Okay. If we stick that in the dictionary, we do this. We eval... Well, can we eval 1? Let's see how this test does. Just push 42. Okay. Okay, so this one is fine with eval 1. This one, eval 3 words. Well, so I guess that's... Well, is that quite right? No, this is different because eval doesn't do the looping, so there's no point to this one. Because we'd have to call it 3 times. Well, there's no reason. Oh, sorry. Anyone else use the empty string? Yeah, I don't think so. So I don't think this test is adding anything. Before it was testing that eval actually ran through the 3 words and called eval 1 with each one. But in this case, I don't think there's any point to that. we just want to make sure eval1 works with one word. It's somebody else's job to get those words there. Okay, now this one's a little more, oh, this is an eval1 test. Okay, good. Let's make sure these run. Oops. Eval just 42, eval calls syntax. Okay, good. And let's repeat this search. We still have eval out there. Evaluate. Okay, global eval. Let's take this out. Okay. Repeat that one more time. REPL has eval1, eval1, eval1. Yep. Okay. Okay, so remove did code eval routine. Okay, and then let's do this rename. Everybody who says eval1 should say eval. Okay. Eval. Rename eval1 to eval. Okay. Rename eval1 to eval. Okay. That puts us... All right. Well, that puts us ready to deal with compiling, I think. I probably didn't expect to get there quite so quickly today. But if we do this... All right. So the situation we have now is we have a bunch of primary words like dupe, add, one, sub, multiply. That may be it. We have several primary words with that primary structure with a block of assembly code with a pointer pointing to it. And we have an interpreter that knows how to handle those. And it also knows how to handle secondaries, which are a block of code. It's a list of addresses of primaries or secondaries and a pointer to a routine that knows how to handle that list of words. Okay, so we have the interpreter for both, but we don't have anything that we hand create the primaries, but we don't have anything that can create secondaries. Let's clean up those tests first. You're right. Let's see. So we had readLine 2 stubs. Yeah. Okay, good catch. All right. So we'll take this pattern. I still want to rename this to like read stub. I think I will. Okay. Okay, well, you know, so easy to screw things up. Let's just okay. Yeah. All right. So the usage is these 4 calls. Input in it, you still got to do. Wouldn't hurt to go down the line. Read stuff in it. Okay, so the thing we're going to read. Read source 3. Source 3 is our 3 words. Okay, that definitely feels like what we should read. I'll read source 3. Okay. And then this line we don't need because we only had 1 line. All right, what's read source? Oh, that's our setup for that. Okay. So we don't need this line? I guess in effect, these are all the stub lines, right? So the stub replaces those 3. Okay, you got to read stub read line. Okay, and now we're expecting source 3A. Yes. All right, read another word. Source 3B. Read another word. Source 3C. Okay. Those input tests. Read with words separated by multiple words separated by spaces. Okay. And we want read source 2. And then this is unnecessary. Okay, that's not so bad. I think we can do the same thing here. Read underscore source 1. Okay. Yeah, those both should pass. Okay, let's try make. Read with the word start. Okay, yeah, that's good. He's using assert equals strings. Read lines are stub. Okay, I guess I can. Oh. Now everybody's calling read line 2. Well, I guess before I delete that, I should make these call read line 2, shouldn't I? No, I should not. I'm going to delete it the other way. Read line. Okay. Okay, all those are good. Yeah, so let's get rid of readLine XXX. All right, now this really can be else stub. Actually, it doesn't matter. Each test is standing alone, so it's no harm. I don't need to make a global out of it. Yeah. Okay. That seems okay. I'm going to pull this data a little closer to the stub. Whoops. The data the stub controls I'm going to put here. Okay. Yeah, no, that would be... If you need to bug, you'll have to something for breakpoints. Yeah, I think that's probably worth it. It's not going to get in the way of the actual REPL app because the test won't be part of it. So I don't think there's any harm. All right. I mean, there's some slight, like, I could make this a macro. You know, I probably would. I don't know. It's hard to know if I were. It's like there's places where I'm not treating it like a real project, you know, and this is probably one of them. I would make my tests much. I'd be more inclined to put macros in for stuff like this, but you know, it makes it harder to debug, and that's a real trade-off in assembly. You know, it's hard to know what you're really putting there. I don't think these two paragraphs are too bad. Okay, so you have to read a word, and we're going to make sure each word is right as we read it. That seems reasonable to me, and I think I'll let it stand. Okay, so I don't think we did anything, but just in case. All right. Did code stub read line 2 rename. Yeah, I don't know how to say this in one thing. Maybe this is okay. Yeah, close enough. Okay. Right. Anything else on input? I'm pretty okay. All right. Input, read a word. We kept him somewhat structured. Where's my REPL? Yeah. Evaluate REPL. Word not found error. Okay, so how's the REPL looking? Prompt, we get our print, read word, eval. Maybe I should pull that in. I don't know. It seems like you should do that whenever you're trying to read something. And it's not the REPL's problem because the REPL's just getting words. What will that do? I don't think it'll break anything. That stuff's all irrelevant. X22 counts, and we use that there. Yeah, let's pull that over. Input. Prompt. Okay, so now you only do this when you're actually ready to read a line. We're going to print the prompt first. It's a little extra coupling, but I think we're okay. Let's run tests. Yeah. Eval prompt. Oops. We'll be needing that. Now there's something else odd here, isn't there? We've got input buffer here. I guess I'm gonna align before I get the address. Why does REPL have this? No good reason. Okay, hey, yeah, so, no, I'm running it just in front of my Mac. So I have a M1 Mac, I guess it is, and it'll run ARM assembly, so. Okay, so what we're doing is we're writing a language interpreter for something that's similar to Forth, except I'm going to cut corners where I want to. And right now we've got something that Forth has the notion of primitives and secondaries. A primitive is like an assembly language routine, and a secondary is a list of routines, whether they're secondaries or assembly language routines. And we have an interpreter that can run with either sets of those. And then we just got the read eval print loop and read word and all that stuff together for primaries. But theoretically, the dictionary knows how to search secondaries, but we don't have a mechanism to create them. So we're going to move towards that at this point. We're doing a little cleanup before we tackle that kind of moderately big new area. Okay. And we're using test-run development, so I'm trying to be pretty strict on that. Make again. Okay, so we have, I don't know what this is, a page and a half of tests or something. Basically, it says pass for every assertion. So when you see 2, that's suggesting that the 2 assertions passed. Okay, but our REPL stuff's still good. Let's run our REPL. And our classic case at this point, because we only have a few words going, is one dupe add, making sure the stack gets 2 on it. All right. I think at this point, well, no, REPL wants to put those words. Okay, yeah, I think that's fine. All right. I'm debating about, do I really want to show the stack every time you get through? And I really don't. But in Forth, there's a word period that you call to print the word on top of the stack. And normally you would just put your own period in there when you want to print. So it's not really a REPL loop per se. Or I guess it's a REPL because L is already loop. Okay. But I think we're to a good place here. I think those tests are right. We've pretty much got what we expect there. It's a little long, but it wouldn't be very long in a high level language. I don't think it'd be too bad. Might be just enough to make me do something. Well, I would have routines built in that would find the next space and pull out words and stuff. So I wouldn't even have to do half of this stuff. My rule for this is I'm willing to use the Unix style calls like read and write and whatever else, exit, but I'm not willing to use the C library. So I'm just giving myself this constraint that I could do this from a kind of minimal setup. All right, now I think this is no longer REPL. This is compiler. Okay, so this was REPL. All right. Let's see. I had some pictures. I did start thinking. It's these. Okay. Okay. So the vocabulary we have, they kind of come in different flavors. So as far as execution, there's sort of a run mode that says when you see a word, do it. And that's what we have so far. If you say one dupe sub, we execute the one, we execute the dupe, we execute the sub. And right away, whenever we see the word, we go and execute it. The new mode we're going to introduce is a compile mode. And compile is definitely more complicated in a sense because what do you do depends on the type of word you've got. Okay, so there are two types of words. We've always talked about primaries and secondaries, but there's the notion of, I use the word meta. They're sort of special primaries that always run even in compile mode. So normally in compile mode, you're in the middle of building a secondary, which is a list of routines, and compile mode says, okay, go find the next word, take its address, and put the address on that list. But if you get these meta words, they're going to say, no, I want to decide what to do. And so the word that colon is the word that triggers you defining things. So colon is going to switch you from run mode to compile mode. And that'll create a secondary and then get you going on filling in new things. Another one is if. So if, else, and end, if you're in compile mode, well, even if you're not, they're always going to run special. So if says, I want to capture the location of the current secondary so I can backpatch it later. And else does some twisting and backpatching, and then end does the final backpatching of going back to that line and zapping in a pointer to a different line. Okay. Now, I think we have the code to evaluate an if. So it's a little tricky that the if that you put in there is not really the if that gets run when you run the method you're defining. So the if that you put in there, I mean, like if you say one dupe add and then if, okay, you got the word if, that actually triggers a meta word that always runs, and it will capture the location and all that stuff. And it'll also put in a keyword if that is sort of a system primitive. Okay. And, same for else and end. They've got their own little tricks. So we have to kind of change our run model to detect what mode we're in and detect what words do things. Okay. So, the metas are funny because in run mode or compile mode, they do their thing. Okay. So if I make a little chart, in run mode, you get a regular word, you just run it. You get a meta word, you run it. Okay. In compile mode, a regular word just gets appended to the current secondary we're building up for the dictionary. And in compile mode, the meta runs the word anyway, just like it did in run mode. And the tricky thing about it is it can switch modes. So colon says we're going to compile something and it switches to compile mode. Semicolon says we just finished compiling something, switch it back to run mode. So those two actions have that effect. And then if and whatever else control structures we do is going to do it. Okay, so I'm not quite sure the best starting point. Well, okay, we can't go to we don't have compile mode yet, right? So maybe let's get the metas going in run mode, and I think we'll get colon and semicolon, and maybe our first version of them, they're just going to echo the word instead of running it. So if you did one dupe add, theoretically you'd have a 2 on the stack, and if I said colon 1 dupe add, it would still have the 2 on the stack, but it would just print 1 dupe add. Okay, and maybe I'll put C colon 1, C colon 2 for, dupe for compile mode or something. Just a very simple flag for us to just kind of look at how it goes in and out of that mode, and not worry about the dictionary just yet. Okay, so I guess it's REPL is going to have to know these modes. And the meta, how we're going to detect a meta, that's going to be interesting. Okay, but I think that's enough to get us going. All right, let's see. Do we need a, let's see. I couldn't see comments while I had Keynote up there. Do you need a meta stack? Theoretically, the if and else and control structures need their own stack, but I'm going to assume we don't need a stack for meta mode, that they will just do it flat, okay? And I think that will get us through, because colon and semicolon for defining things, and then if, else, while, end, whatever, repeat, whatever things we add for control structures, those don't need, those need a stack for the control structures, but they don't need to, we're not going to let you define a colon as you go. Now you could, you definitely, if you made your language such that you could create methods inside methods or something like that, you would definitely have to have a stack of metas as well. If I were doing JavaScript or Lisp or Elm or, some language where it's comfortable creating methods like that, I would have to definitely put in a stack. But I believe we can just get in flat on the metas, the regular metas or definition metas, and then compile mode, a separate stack for control stuff. Now, in the fourth implementations I know, which is not very many, they do use the regular stack, the system stack, as their control mode stack. I don't think that makes sense for us. It might be doable, but I don't know. The if thing, like how deep are we going to have nested ifs and nested structures and stuff like that? I'm fine to say, like, you get 20, and if you go over 20, you got to split it up. If I were coaching you to write code a certain way, I'd probably tell you to split it up after 1 or 2 or 3, So, I think we can give it a fixed depth and call it a day on this one. Again, a real language might have bigger restrictions, but 10 deep is pretty deep for handwritten code. If you were generating code like people do in C, I remember when they first, the C standard first came out, I don't know, it must have been 1990 or something. One of the things they did was they made sure that certain constants that a compiler would have for how big an element could be and all that stuff, they raised it because they knew people had been running into generating code, and then implementations would fall apart because they only allowed 20 deep control structures or whatever, whatever the line was. It was not very deep in some cases. So they would do things like say, you must allow 256 nested if statements or nested control structures or something. I don't anticipate anybody using this, period. This is enough for me to prove out some techniques and not really run. I don't know what that would take, but anyway. So I think what we'll do for next is let's we're gonna have to figure out, how do you know a word is a meta word? And I'll tell you, I don't know. We got to do something. So we're either going to throw an extra bit in somewhere in the existing dictionary, or we're going to keep a separate list somehow that says these are the metas. Okay. Does recursion suffer from the limit? Not Not in our case because, well, we're using the system stack for the limit in our recursion. That's the interpreter. Remember, it calls itself recursively when it finds a new, like if you call a secondary in the middle of a secondary, it calls that same start 2D recursively. And that's all relying on the system stack to make that stuff work. So usually your system stack's a pretty decent size. I don't know what it defaults to or anything, but when I blow up a system stack, it's usually pretty darn deep. I don't know if that's something set in Mac OS or something set by their compiler. Excuse me. Okay, so I guess let's see. How can we? All right, let me move this up a little bit. Okay, so make sure we're checked in. No, we're not. Make an ACP. Well, let me see what the diff is. Oh, this is input. Oh, we added the prompt. Okay. Yeah. Alrighty. So, recognize. Okay. Let's split this up. Let's find a way to enter exit compile mode. Allow you to enter exit compile mode. Okay. And then for now we'll just print when you run things in compile mode. Okay. Well, I guess that's a REPL thing. Where's our actual REPL? Okay, so this is eval. Yeah, I guess in compile mode, we need to make an explicit decision when to eval. Okay, so I don't know if I should pull this out. I guess I should, because I can't test it with the REPL running. That's not going to be good. Okay, so let's pull this out. Now I'm wishing my word. I want to change my eval word again. All right. Eval all. Eval any. Eval. Well, I'm gonna make something out here. What that is. Okay, so we're going to refactor a little bit here. So I'm going to make REPL all. Well, I don't have to do that. Okay. And he's going to have to store this. And he's going to have to do good citizen on the way out. Okay. And right now, all he's going to do is call eval. All right, because we're calling a routine, we have to have the prologue. All right, and this is going to be eval all. All right, this should behave the same. Yeah, there you go. Local symbol L eval. Oh. Okay, and let's make the REPL. Eval needs to be able to run the exit command. Yeah, we don't really have one right now. I've just been doing Control-C to get out of the loop. But okay, like that. That's probably, we could probably set up a handler for that. If we had one, yeah, it could do it. I don't see we might have to do some flagging or something, but we could just run a Unix exit. We have that thing somewhere, so okay. Right. So that's all good anyway. Extract method L eval all. Okay. So now we can test compile mode, right? Because we've got a, well, let's make an entry point. I find it annoying that I have to do this stuff for the tests, but okay. Okay. Well, let's push that. Yes. Oh, I see what you're saying. Value needs to run the exit command. Yes. Yeah, and I think that's where we're going to be changing things. Interesting. What should it be doing? Can we detect it? Well, we'll see. All right. Yeah. So we don't have commands like that. Enter command mode. Okay. So I think, let's see. What are we going to do? I want to be able to say colon dupe semicolon, and I want it to not evaluate the dupe command, but just print it, maybe with a C colon in front of it, so I know it's in compiler mode. Yeah, so I think we do need to add those to the primaries. Right, yeah, so let's add colon and semicolon to the primaries, and then we'll add the global flag that they're going to modify. So I think adding them to the primaries is going to be kind of, well, they're going to start out minimal, just returns, but they can run. They won't do anything. All right, so yeah, let's do that. Been a while since we looked at any primaries. I think they're all in core. Okay, so we got push. Right, let's add those. New line. Okay, before push, let's put ours here. Okay, so this is colon, and it's enter compile mode. That's all we're going to expect out of it so far. Colon return. And then semicolon. Okay. And let's find references. I guess I make globals. All right. And if we find this, we should see some data where it's being shoved in there. Interpreter test, where's the... Well, that's a test. It's got to be interpreter. Oh, no, that's that. It's not in REPL. Now, dupe add and sub work, so what's going on? Dupe. Right. Oh, main. Okay. Yeah, there's all our words so far. All right. And let's add one or two. Calls colon and semicolon. Okay. And I guess what they could do... I suppose we could give it some data and print itself for now. L colon. And that means I need to do our prologue. X0 gets L colon. BL print. I guess a new line wouldn't hurt. And okay, so this is L colon. Semicolon's very similar. Okay, so with those now, okay. Or if I say one dupe add colon, one dupe add semicolon, I expect to do one dupe add, which will push a 2 on the stack, and then print the colon in colon, and then execute one dupe add again, which will push 3 on the stack, and then semicolon print as semicolon. Okay. Whew. Alrighty. Let's take those. Introduce bare bones colon and semicolon. Okay. So I think we're ready to write a test. Is it? No, we're ready for a break. Let's take a break, then we'll come back, write a test, and make sure we can switch modes with our colon and semicolon words. All right, so 3 or 4 minutes and see you back then. Welcome back. All right. Let's see. So we're going to look at the REPL. And we're going to test this function. So if you're in compile mode, well, if you're in run mode, you should do this line, BL eval. If you're in compile mode, you should do the compile stuff. Now, again, I'm kind of okay putting in fake stuff for now. Just to kind of make sure we're on track with it. Yeah, I think that's the thing. It's like we're going to test if somebody says enter compile mode or exit compile mode, or maybe enter run mode, enter compile mode. The right thing should happen up here, and we don't have to care what it does. But I don't know. It's like I don't want to substitute functions all the time. That's kind of annoying. I mean, a thing you could do. I don't know if this is good or not. No, because you have to eval sometimes in compile mode, right? Because we mentioned those meta words that always want to be evaluated. I was trying to think, like, could I just have you, instead of entering modes, could I just have you swap the current evaluator? So put this in some sort of register variable, and then enter compile mode is BL, turns the register into the compile function, call the compile function, and then this one turns it back into the eval function or something like that. But maybe for now, I don't know. Maybe it's enough to see the flags change. Yeah, that's tricky. It's the same thing you face often with tests, right? I mean, it's especially if you're kind of coming in afterwards and you're trying to figure out how can I make this testable. Well, one thing I could do. No. I don't know. Compile needs, it's going to look up when it sees a word like dupe. It says, "Oh, I'll look that up in the dictionary, and that address is what I'll put into the end of the dictionary where it's being built. I'll put it there, and eventually, do that. I mean, maybe we need to do that instead and just get the actual work done." Test with 1. Yeah. I was kind of hoping to get the flag working before I tried setting up the dictionary. And I feel like I still can. I mean, eval. If I'm evaluating the words, maybe I can just monitor the flag. That's a test. Okay, so test start. Yeah. I think I'm okay that it doesn't actually behave that. I just want to make sure the flag. No, is that going to test anything? I don't know. I guess writing the test will tell me something. Okay, so the setup for this. I mean, okay, I guess what I want to do, dictionary init, dictionary header. I don't want to test colon and semicolon, right? That doesn't make any sense. I guess I want to put the thing in compile mode. I mean, I don't know. We got registers, right? I mean, I could designate a register to be, I don't know, it's going to have to be the mode. We're up to 22 and we got 28. So maybe 23 is the compiler. Okay. So let's say move L compiler. No. Load address. X0 is L compiler. Test compiler. Test compile. Okay. And then I'm going to move that. Well, no, I'm going to make that X23. Okay, let's catch that design change. I have a page for that somewhere here. Okay. Okay. And then L-test compile is going to be a little word here. And, well, he's going to return. Okay. So if you call the compile mode, and then somewhere else we have to keep that flag. Ooh. I don't know. Well, I'll put it in there for now. We may flags. Okay. We may have more flags later. Okay, and then I'll move X24 gets 1. No. Okay, I guess this first test is going to be let's see. Eval all calls eval in run mode. All right, that's where we are. That should just pass. So let's do this, and then bl eval all, which means we have to do the prologue. Oh, we already do in the start. Okay. Eval all. And then we got to make this be eval, right? It gets X0, I think. X0 is the word to execute. X22 is current word in. Well, it's really the next word. Okay. Right, so X0, whoops. is high, well, now let's just do 1. It's an easy one to check. Okay. Right. And if you do this, I want to assert, well, I'm going to load address. Oh, no, we have it already. The virtual PC and virtual SP. So VSP, VSP is already the address. So, we're going to load X0 with contents of X19. Except I think that's got to be -8. Did I say? I think it points to next word to write. To push into. Okay. So given that X0, X19 -8. One word back. Okay. And then load move X1 gets 1, and then BL assert equal. Okay. Eval all calls eval in run mode. So we'll set up the pointer for eval for compiling. Okay, we don't need to do that here. Okay, X24 is our flag, says we're in run mode, and we're going to load the word to evaluate and call eval all, and then we're going to come back and check that the stack contains a 1. Okay, now this should just run if I include it in the run list. Okay, eval all calls eval in run mode. All right. Okay. It fails. What happened there? 42. Oh, we didn't clear the stack. Load address L eval test stack, yeah. He pushed, he does not pop. WZ, sorry, X0 into X19. Okay, so we're pushing an empty. We're clearing the stack. What's at the stack? We set run mode. Okay, so this should be just like a normal test for us. We haven't changed any behavior yet. So, well, interesting. Okay. I think I can debug this faster than I can. Okay, let's run. Okay, branch, we'll skip. Step. Okay, now we're into our routine. We're setting the stack pointer. We're zeroing it out. We're loading our compile. I'm not sure what that is. We're loading the pointer to the one word and calling eval all. I'm going to skip. I don't know, LDUR unsigned register maybe? All right, let's look at X0. Can you create a... yes. Yeah, that'd be a good thing. It's .equ, I think. All right. So let's look at X19. Okay, 4028. And then if we step, well, that should be 428. Okay. That's where X19 points to. If we move... Let's go back a little. 4020. Well, I'm suspicious of my X19 now. Eval test stack. It's up here somewhere. Okay, it's blanked out. Okay, we load that address. Oh, I didn't do dictionary and net. One should be, is it push one? Just push one. Okay, I think we had no dictionary words, so we were going down a bad path, maybe. Okay. Yeah, that should be passing. All right, let's get that equated in there. REPL tests. Well, I don't know. Equate, I think it's a macro-like thing. Let's see. equate symbol to expression. Well, let's try it. Equate run mode to 0. Equate compile mode to 1. And I'm pretty sure it had the comma. Yep. Okay. Yeah, you can't use it in the assembly. Yeah, we don't have access to that word here, do we? Yeah, I don't know. I'm not quite sure how it plugs things in. But this should pass. Make. Well. Oh yeah, I don't think it. Okay. Add confirming test for running in eval mode. Running in run mode. Okay. And I think now we can, well, next we'll write the test that's going to fail. I think that'll be, move us forward a little more. Okay. So BL, I'm going to put this down lower. Okay, so we'll create the same dictionary. Actually, it doesn't matter. I don't think it does. I don't think we need it for compile mode. I'm not sure. I suspect it's more like a preprocessor, in which case it'll complain if we reference it in the test. But I don't really intend to reference it in the test because I'm kind of using the side effects of what I do to verify them. So it'll be okay there. Colon and semicolon won't have access though, so we may have to find a place to put it in a macro file or something. But the reading of this is a little ambiguous to me. It sounds like it's stored as a symbol, which is a little like, well, if you're compiling C and you have a variable declared, I think that variable is a symbol at that point. So it may have deeper meaning than I'm giving it. I'm just not sure what it does. Okay. All right. So compile mode. Oh, yeah, this is where you're complaining. Okay. So let's see what happens. This is run mode. And this is no harm. I'm just going to, let's see this fail before we go further. Oh, nuts. Okay. So, I don't know. Assembler, we got these macros. Assembler macros, Unix functions. That's very low level. That's kind of tied to Unix. I think it's a different kind of macro. Dictionary REPL. Let's make a new macro. I'm not sure I'm doing this in the best way. AS unit macros. Let's make it down here. We'll make a REPL macro. And I'm going to move those equates in here. I'll fix that momentarily. Okay, and then this thing needs it too. And then our make file should reflect it. Macros. Okay. Okay, so that's all right. Okay. REPL tests. Okay, he's saying run mode. Now he needs to say compile mode. All right, and I guess that doesn't need a comment anymore. One small leap for variables. Okay, so the eval word is the same. Now, I guess what I want to do... I'm going to put some data in here. Okay, so this is L capture. Ten bytes of zeros. Or 10 bytes of zeros. He calls eval all. So now my assert is different. I want to assert that L move L capture load address L capture to X0. And load address X1, our expected string, excuse me, is this. And I'm just going to write the word for now. I think that'll be enough. Well, I think if it's a symbol, I think the way it treats it is it's got this name defined, and anybody can kind of compatibly define it, and it's fine. But it's sort of defined across the files, so they're each saying, "Oh, I'm making this equivalence." But if one does and somebody changes it and stuff like that, then things get messy. And that's they had an error version too, and maybe that would be a better. Well, thought I saw it. Oh, maybe equate had a nearby. Yeah, equiv signals an error. Right, and that would be the same. That would be the error that you trigger if you defined a function f over here and another function f in another C file. It would compete for this and complain. But I don't know. It's using if def, so it's got to be more macro-y. Yeah, I don't know. I think what we're doing will work. That's, I mean, it accepted it as a constant and used it, and hopefully we don't redefine it. You know, in a big application, if we were writing an operating system, we'd be much more worried that somebody would come along and redefine that variable accidentally. All right, so what I'm assuming is going to happen, okay, this should fail, but what I want to do is copy, I want to make this compile method copy x0 to L capture, because x0 is the word to evaluate. All right, so this will fail because it'll get you know, if I run it. All right, I expect this to fail with an empty string instead of a 1. Well, so much for that. Undefined symbol eval all calls x23 in. Referenced from start. I lost some of my word, I think. Oh. That would do it. Okay, should fail. Good. Empty string versus 1. All right, and now I want my compile routine. He's got x0. Okay, so he's going to load address. X1 is the target, which is L capture. X0 comes in. X0 is the input word. X1 is capture, load address, and then string copy Z. Okay, and I have to do my prologue. All right, so he's going to call the string copy Z. So I don't know. I'm at the point of doing this so many times, I should be making a macro for that. Okay, because he calls another routine, he's got to do this. X0 is the word, L capture is where we're going to write it, and we want to do a string copy Z, and that should also not work. Okay. Even if it blows up on the string copy Z, right? Because we don't actually enter the mode yet, so we have to write the code to, that's going to force us to do this. Okay, so REPL. Where's REPL? Eval. Okay. So we'll have to test. How do you test without doing anything? Let's look at our compare instructions. Well, let's try b.eq. Okay. And he's got to load. And okay, I guess we could and it. And I'll use x1 of x23 is our mode, and 1. Well, let me do that. Yeah, good. Okay. And then I'll compare dot Oh, I just need to compare. Okay. Compare. Well, that's actually okay. Compare x1 to, well, let's make this compile mode. Okay. And if it's equal, well, if it's not equal to compile mode, we're going to evaluate. And if it is, we're going to call, oh, that should be x24. We're going to call x23. Now, make sure my test used x24 here. It did. Okay. So, and in the end, we got to join back up. Branch rejoin. Well, and eval all. Okay. Test for compile mode. If it's not compile mode, then we're going to go to evaluate, which is this BL. I kind of want to do this. I don't know if that's better or worse. So if it's not compile mode, it's run mode, and we're jumping to evaluate, BL eval, and fall through. If it is compile mode, then we're going to call our compiler and then branch to the rejoin the thing. Okay. I expect this to pass. Okay. Oh, all right. Well, I think, yeah, we did try that. That really annoys me. But I can, well, if I think of C symbols, it makes sense, but it just seems like they're treated like defined. So I don't know. It's just weird. I really would love to have those things as variable names of some sort. And that's why one day I popped up M4 and started thinking about, should we do that? And I don't know. All right. So, and did we set x24 in our test? Yes, we did. Okay. I think Well, either I've messed something up between the data and the text. So this is aligned. This is aligned. Okay. It doesn't seem quite so likely to be the problem then. How about here? Same thing. Okay. I'm guessing this gets called and it doesn't do what I want it to do. All right. Well, test compile. Load address x19, x24. Where's x23? Oh, no wonder. Okay. They load L capture into x23. L capture. Yeah, no, I think this is what we want in x23. Okay, so x23 is the compile method. We're going to call our compile method instead of a 0 probably. Although I would expect a bus error, but okay. Yeah. Okay. So that seems good. Okay. I guess what we have is our eval loop calls eval when we're in eval run mode and a compile when we're in compile mode. Okay. And that test shoves in its own compile function, so we're kind of okay. So where is REPL? Okay, so part of our init, right, we need to capture this. We need to load address. x23 should be our compile method. Now, there's a slight problem. Compile doesn't do anything yet. Okay, but that is what we will work on next. Compile, and right now we just return. Okay, so I think with this, the test should still pass. And then the REPL should be a little funny. If I do one dupe semicolon 1, one dupe colon 1 semicolon add. I think I'm going to get a 2 on the stack. Okay, and if I add again, I'm going to blow something up. Oh no, I have 2 and a 1. Again, no. Oh, we had a 0. Okay, let's get into the junk. Yeah. The word stack in is a very good sign. All right, so what we're doing now is colon and semicolon, basically all they do is switch modes. And our compile mode just ignores any word it's given. But, now, wait a minute. We don't have meta words yet, so there's nothing to do to fix that. So that's not doing the right thing, I don't think. Or well, it's doing what it's intended to so far, but it's not executing the semicolon, I think. So if I do this one add sub, I do. Oh, wait a minute. Did I finish changing those routines, or do they just do nothing? Load address, semicolon, print. Oh, yeah, they do nothing. Okay, we're ready to test those. All right. Cool. Okay, so we don't go into compile mode. We just print. All right, that's... it ignores... Well, it prints in semicolon, and then it does a 1, an add, and a sub. We see the 0 because that's our empty stack we plugged in. And then 1, add... I don't know. Something's funny. All right, but it's a true fact that these two don't do any changing of modes. Nobody does yet. All right, so... is it the right time? Yeah, let's start writing the test. But yeah, we just have a minute, so... Okay, so I put those up pretty high. Yeah, let's do it up here. Test start, colon, enters compile mode. Test end. And then I'll move x0 gets 0, move x1 gets 1, and BL assert equal. Assert equal. All right, now I'm not calling it, so this should pass. Whoops. Okay, I'm going to check it in like this. Make eval all call compiler in compile mode. Okay, and then if I add that test, this test should fail. Good. All right. Well, we'll pick up there tomorrow, 2 to 4:30 Eastern Daylight Time, or 6 to 8:30 p.m. UTC. We will pick up with compile mode, and I think we'll probably also get into the dictionary stuff. I don't think these two words are going to take very long. So we'll do compile mode, and then we'll work on the dictionary so it can hold secondaries, and then we'll work on compile mode, writing stuff to the dictionary. We're going to have to do something. We're going to have to recognize meta words in there too. So maybe that's the big thing we'll do after we get these two little tests running. All right. Well, thanks for joining, and have a good evening. Take care. Bye-bye.